Okay, so for this, we need to find two functions that are one is bigger than this function always, and one is smaller than this function. So cosine of theta, recall that this is always between -1 and 1. But cosine of theta, when theta is 0, right, the graph looks like this. It's actually very, very close to 1. So here's 0, here's 1. Around that region of the cosine curve, right, the value is it's around 1. Okay, it's around 1, but less than 1. Okay, so we know for a fact, because x to the power 4, right, x to the power 4 is always greater than or equal to 0. And we know that when x is approaching 0, cosine of 2 over x is this right here. Okay, so I'm going to write that again. I know for a fact that x to the power 4 cosine of 2 over x, this has to be greater than or equal to 0. Okay, and consider the product here. So we just said this is close to 1 but smaller than 1. If you have any number and you multiply that number by something smaller than 1, the number is going to decrease. So this must be smaller than or equal to x to the power of 4. Okay, so this is the condition you have to come up with first. Now you can say since, right, the limit of x approaches 0 for x to the power of 4 is approaching 0, and of course this is obviously 0. At x approaches to 0, x to the power of 4 cosine of 2 over x is squeezed between two zeros. Right, so therefore, by squeeze theorem, the limit x approaches to 0, x to the power of 4 cosine of 2 over x is equal to 0. That's the proof.